10 reasons why amino acids started life. When I first started speaking about amino acids, I had 6 reasons. Over time, as I learned more about the abilities of amino acids, the list got longer. Currently it's at 10, which is where I'm going to start. 10 is that the catalytic action of amino acids in an enzyme are 1,000,000-fold the reaction that would occur normally, compared to hundreds of times by inorganic catalyst. So an inorganic catalyst would be like a candle, and an enzyme catalyst would be like a laser welder. That's the amount of difference in the amount of energy that can be catalyzed in these reactions. So much more easier to catalyze reactions with amino acids. Second, number 9 is that they are weakly bonded. Now, normally this would be a disadvantage, but in this case, amino acids only need a strong acidic or basic, depending on the conditions, for them to dissociate and then be able to be reutilized. This normally would be a disadvantage, but compared to inorganic compounds, once they react, you cannot use the same conditions to disassociate them as you did to unite them. Once you create that association with inorganic matter, you have to find conditions that are totally different from the initiating conditions. But that's not true with amino acids. Amino acids can go back and forth and bond easily and dissociate easily, which allows them to be easily reutilized. That's why when we consume nutrients, or any organism for that matter, they only break it down until the amino acid. They don't go any further to break it down further into elemental atoms. They maintain it at amino acids, which is more efficient. Second is all biomolecules are formed starting from amino acids. I was even amazed to find that from amino acids, using other amino acids, you can create sugars and the precursors to RNA and DNA very easily. Number 7, they self-assemble into repeating structures without assistance from any other molecules coming in and trying to organize them or program them. They automatically form either alpha helixes or beta sheets. And those are the 2 structures that are most common in most enzymes, not all. They spontaneously bond to each other. You will never find a single amino acid in nature. They come either associated to each other or with other things, making it easy to create peptides depending on the condition for amino acids to unite. Unlike inorganic material, they only need water, and I should add carbon dioxide, which is what life uses to maintain the proper pH and unite them and use them to react to form proteins, enzymes. Their proper orientation depends only on water. With inorganic materials, you need all types of chemical, what do they call them? Media, certain fluorocarbons, aprotic, polar types of media in order for the reactions to occur. With amino acids, the only thing you need is water and carbon dioxide, which was abundant during the Hadean epoch before biology became the dominating force in geophysics. Number 4, they spontaneously form hydrogen and sulfur bonds, which are they're spontaneous associations, attractions. They're not true covalent bonds. But what they do is create structure and give the proteins rigidity, which makes them more useful than inorganic elements or chemicals. Number 3, they keep their chemical integrity. So once they curl up and form an enzyme or any protein, they can be easily extended and disassociated from its final orientation without forming cross bonds like you would with inorganic material that would form crystalline structures. Any atoms that come near it would automatically bond and form a covalent bond, which would be unbreakable with the conditions that it initially occurred. With amino acids, you just put the initial conditions back and it would unfurl without detrimental cross bonding, which allows it to keep its chemical integrity over and over again. They come in 500 varieties. So that means that every element in the periodic table would have a representative in amino acids. So life would just need to collect an amino acid that has whichever element it would need for any reaction. So it would be much easier for life to find an amino acid provided by asteroids and comets, because for reason number one, amino acids are ubiquitous. They're literally raining down from space, especially back in the late heavy bombardment. There was so many asteroids, so many comets, so many meteors. And since we've been studying this since 1969, we have discovered over 500 different varieties of amino acids in meteorites falling down on Earth, which makes it a most available modular chemical in the universe, or at least in our part of the universe. There was no need, and probably there wasn't, any freely available elemental compounds on Earth during the Hadean era. So what would have been readily available is the water full of amino acids, because both the water and the amino acids came in abundance in all the meteor strikes during the late heavy bombardment, which is what most agree should be what gave us our oceans and all of our volatile compounds, which allowed life to originate on this planet. Thank you.